Hello everyone, welcome to this session of beginner ROS tutorial with Robot Development Studio. This is the last in this series. Um, in this part we will see, we'll explore capabilities of this platform. Okay, how much computation you can do on it. Can we run Gazebo, RVIZ, etc. on this? Theoretically, yes. So for this, what we will do is that we will install a custom package and explore how it works. So to begin with, we start a shell. Okay, and in this case, what you will see here is that you have this simulation button. We want to launch Gazebo simulation. For that, we'll make use of this button. So if you choose the launch file, it will ask for the launch file here. So to do this, we'll have to install our packages within the simulation workspace. So we go to simulation workspace and cd src, and here we will download the package wget. Now we'll use git clone -b motion stps and so it downloads the Gazebo experiments folder, cd Gazebo experiments. It has a documentation, you can go through it, that explains about how to build this SK board. Basically it implements a simulated mobile robot. So what we will do, move SK board cd. We do not need Gazebo experiments, so for the time being we'll remove it. Gazebo experiments. Now we'll go back here and run catkin make. Hopefully everything should be fine. Then only we'll be able to move to the next step. Yes, as you can see, it built all these packages, so you have all necessary files for running the simulation. And then we do source devel setup.bash. Now let's try if we can load the simulation again. Choose the launch file, and as you can see there is a menu button here. If you click on that, you see all launch files are available. So what we do, we run sk port_world launch from this package. So we do that launch. As you can see, it loads the robot along with the world environment, and all right, now we'll see if we can able to make the robot move. So we'll run ROS run skboard motion. We'll implement a basic obstacle avoidance algorithm. So you see, you can see the robot starts moving. Let's see if it can avoid the obstacle successfully or not. So it is rotating, but it's getting stuck more or less. This doesn't happen on my native machine, so that means on my own machine it works fine. I don't know why it happens. Maybe the response time is slow. So let's see. If I stop this, you see the robot is still rotating. That means the response is comparatively slow. And if I run the algorithm again it starts moving. So what I believe that the response time is slightly slower, so probably it will get stuck there again. It's rotating, probably it's taking more time than usual. See, so the case is changing here. It is responding, but somehow it is not able to come out of it. I stop it. The moment I stop it, you see it is able to still rotating, right? And if I run it again start moving. This behavior doesn't happen when I run the same program on my own machine. Alright, there it perfectly rotates and avoids all the obstacle. So so anyway, it is working, so I'll stop it here. Then what I'll do is I'll start another terminal and we'll see if we can run the G mapping demo. CD simulation workspace, source devel setup.bash, ROS launch, skbot navigation, G mapping .demo.launch is available here. Okay, now in another terminal we'll start the graphical tool, that means desktop first, and then we'll do CD simulation workspace, source devel setup.bash, now ROS launch, now skbot description, skbot RVIZ G mapping. We want to launch the RVIZ corresponding to the G mapping demo. Let's say, and if we check the desktop, we have this RVIZ window open. Let's maximize it, and we add here robot here. Robot model. Okay, then we'll add laser scan. In laser scan, choose the right topic, skbot laser scan, and let's increase the size of the scan to 0.05, and then add a map here. Let me see. Yeah, map. Now map, you point it to /map. So you see it is saying the RAM usage is too high. It is not able to run the program because RAM usage and CPU usage is too high. But anyway, we'll just for the timing we'll see how it works. So we have added all the components, and you see as it moves, it is building the map of the environment. Now if you run the obstacle avoidance algorithm now, your CPU usage is too high. Robot moves and map is performed, but it is very slow, and it will not work because the CPU usage is too high. So this is the limitation of this online platform. You can of course upgrade it and go for a better configuration with GPUs and everything, but that will cost you money. So my conclusion is that if you want to do really serious work with ROS, it would be better to install Ubuntu and ROS yourself, which is completely free, and then you can probably do more complex programs. Alright, so it's just a demo, but nevertheless it's a good platform, and a lot of basic programming can be tried out. There are a lot of tutorials available that explains how to do a lot of programs. For example, how to use ROS navigation stack, how to run various robots. For example, if you see, if I go to simulation, I can add lot of robots here. Alright, and lot of tutorials are available about how to program with this kind of robots. So to understand how things work, it is a very good platform. So even though you cannot do heavy computation with the basic account, but you can certainly explore all these robots and write a lot of codes yourself. Alright, so we'll stop here. We just wanted to show that how much we can do it, how much load we can give to this platform. So thank you for your time. Hopefully it was helpful to you. Goodbye.